Okay. And we're in here until 10:55. Okay. All right, so when I'm looking at these notes, that we start with probability versus odds. Now, I will tell you that we're going to do mostly probability, but those are kind of two special words that we hear when we're talking about this stuff. If you are into like gambling or betting, you probably have a decent understanding of odds or probability. That's not something I'm super familiar with, so I broke it down as easy as I can. So when I talk about probability, I mean the number of successful outcomes or the number of successes over the number of total outcomes. So how many times can you be successful or get what you want, and then how many total opportunities are there? Okay. And let's actually, while we're with this, let's just do an example, okay? Let's do a coin flip. If I'm flipping a coin and I say, what's the probability that I get a heads? 50%. I want this written as a decimal. So how many heads are there that I could be successful with on a coin?
2.
How many heads?
Oh.
1. How many sides are there of a coin? 2. So you're right. Half, 50-50, those are like different ways that we talk about it. When I talk about probability, I'm going to think of it just as fractions. So if I'm flipping a coin and I want a heads, or even if I want a tails, that probability is 1/2. Okay. Now, while we're talking about it, let's compare that to odds. Odds is the number of successes over the number of failures. Okay, so success over failure. So in a coin toss, what's the odds that I'm going to get a heads? 1 out of how many? There are 2 failures of a coin toss. How many failures are there? If I want a heads, there's 1. Now, again, if you're doing like betting or whatever, you may label it a little differently, but we're thinking success, actual number of successful times, actual number of failure times. If I flip a coin, there are 2 sides. You either have heads or you have tails. So I've got 1 success, I've got 1 failure. Same idea. Let's think about rolling a dice. Let's do, again, just some basic like probability work. We often talk about coins. We also talk about dice. What if I say, what's the probability that you roll a 4? How many? 1 out of 6. Good. There's 1 side that's a 4, and there are 6 total sides. What are the odds I roll a 4? How many are successful 4s on a dice? 1, and how many are not 4s? 5. In my last class, they were like, oh, okay, does that mean that the odds is always 1 less than the total? Not necessarily, it's on what we are wanting out of it. So like, what if I said, what's the odds of rolling a 1 or a 2 on a dice? Let's actually do probability first. What's the probability of rolling a 1 or a 2 on a dice? 2 out of 6. Or 1/3. I moved it to probability. So if I just want a 1 or a 2, there are 2 sides that are 1 or 2 on a 6-sided dice. So that's a 1/3 or a 2/6 opportunity. Okay. What about number of success over failure? What if I do odds? What's the odds of rolling a 1 or 2? 2/4. Because there are 4 sides that aren't 1 or 2. And so if I simplify that down, that's 1/2. So see how the odds and the probability don't always match up. It just matched up really nicely when we just did 1 of each.
So basically, it's the number, the total, and then minus whatever.
So failures you can think of as total minus success.
Okay.
Yeah, very good. We're not doing a ton with that, but we are going to do a lot of probability today. So we'll think about like how many times you can be successful over how many total opportunities that we have. Okay. I will say in this first chart, we have already dealt kind of with the proportions or the probability here, because the probability of you getting something is the same as that percentage, that proportion. So in these, on all of number 2, all of number 1, we will not do any fractions because it's already written in a decimal form. Okay. So it says Maggie has a bag of M&Ms, as does Elizabeth. Each girl has counted her M&Ms and has discovered the following proportions of each candy or each color of her candy in her respective bags. See the chart below. So if I look at Maggie's bag right here. So Maggie has 0.3 of her M&Ms are green, 0.2 are yellow, 0.2 are red, 0.2 are brown, 0.1 are blue. How much is that all together? It should be 1, right? Or 100%. So 30% of her M&Ms are green, 20% are yellow, 20% are red, 20% are brown, 10% are blue. So if you don't like the decimal and you want to think in percent form, that's okay. We're gonna get to that eventually, but we have to keep it written in this decimal form to start. But if you want to think in your head 30% versus 0.3, that's fine with me. And the total amount is 100. Same thing over here. This, if we add all those together, that should also equal 1, which makes sense because that's out of 100%. Okay. So we're gonna look at each person's bag. Sometimes we're gonna choose from both, sometimes we're gonna just choose from one, and we're gonna see what the probability that we get that M&M color is. So if an M&M is, if a candy is chosen from Elizabeth's bag, what's the probability that it will be green? If I go to Elizabeth's bag, 20%. It's gonna be just 0.2, which is that 20%. If I'm just looking at one, it's really easy, just read the chart. What about if we choose a candy from Maggie's bag? What's the probability it will not be yellow? 80%. I don't see 80 anywhere there, Sophia. How'd you get 80? Good. 1 minus 0.2 or 100 minus 20. So we want everything but the yellow. So we want 0.3 and 0.2 and 0.2 and 0.1. Everybody okay with that? Okay. What about if a candy is chosen from each bag, what's the probability they will both be red? Okay, let's go from Maggie's bag first. What's the probability that it will be red from Maggie's bag? And, oh, sorry. What's the probability that we'll get a red from Elizabeth's bag? 30%. Okay. My question here, what are we gonna do? What's the operation we're gonna do between them? I'm not gonna add them. I'm not gonna subtract them. We're down to 2 more operations. We're gonna multiply them. When I want 2 things to happen at the same time, I want both of them to be red. I don't just want one to be red. I don't want the other one to be red. I want them both to be red. That's our multiplying, okay? So again, I got 0.3 from Elizabeth. I got 0.2 from Maggie. 0.2 times 0.3 is 0.06. And that is 6%. Pretty low percentage actually. Okay. What about the next one? If a candy is chosen from each bag, what's the probability that neither will be brown? What's the probability you won't get a brown one from Maggie's bag? 20% is you do get brown. What if I don't want brown? 80%. Good. And then what about from Elizabeth's bag? What do I want if I don't want brown? Or what's the percentage of? Brown is 0.1. 90%. What am I gonna do between it if I want them both to not be brown? Multiply again. And when I multiply those together, I get 0.72, which is 72%. Okay. All right, the next one says, if a candy is chosen from each bag, what's the probability that the first one will be green and the second one will be blue? Okay, we've always been going from Maggie to Elizabeth. So Maggie's our first one, Elizabeth is our second one. So what's the probability we're gonna get a green one from Maggie's bag? 30%, very good. So 30%, and that's coming from Maggie. And then we want the second one to be blue, so what's the probability in Elizabeth's bag we get a blue? 20%, good. Now what am I gonna do here? Multiply again. I want the first one to be green and I want the second one to be blue. I need both of those things to happen, so we're gonna multiply. So that becomes 0.6 or 0.06 again, which is 6%. Okay, now that's different than the next one where it says, if a candy is chosen from each bag, what's the probability that one of them will be blue and one of them will be green, okay? In this case, I'm okay with either of 2 scenarios, okay? One scenario is that we get, how am I gonna write this? We could get a blue from Maggie and we could get a green from Elizabeth. I'm okay with that situation, so we're gonna indicate that right here. I'm also okay if we get a green from Maggie and we get a blue from Elizabeth. And my letters are terrible there. So I'm okay if we can get a green from either one of them, and I'm okay if we get a blue from either one of them. So we have to look at both of those situations. Okay. What happens if we get a blue from Maggie and a green from Elizabeth? What 2 numbers do we have there? A blue from Maggie will be I think Maggie's 10%. And then a green from Elizabeth would be 20%, good. We're gonna multiply those together because we want both of those things to happen. But we're also okay if we got a green from Maggie, which is what? What percentage is the green from Maggie?
1%.
Green from Maggie?
30%.
0.3, yep, 30%. And then what about a blue from Elizabeth? 20%, good. That's actually what we just did on the problem above. We though are okay if we get a blue from Maggie and a green from Elizabeth, or we're okay if we get a green from Maggie and a blue from Elizabeth. When we have two situations or multiple situations that both we're okay with, we're gonna add those two decimals together. So we're gonna do 0.1 times 0.2, we're gonna do 0.3 times 0.2, and then we're gonna add those numbers together. So 0.1 times 0.2 is 0.02, 0.3 times 0.2 is 0.06, so that is 0.08 or 8%. Right. Yes.
So I'm kind of confused for E,
Mhm.
wouldn't you, 0.2, since you're taking one out of the bag, would that 0.2 turn into like out of 9?
Ooh, okay, I like what you're thinking. However, do you notice in each of them, we're choosing one candy from each bag? I'm not doing one from one bag and then going back to that same bag and grabbing another one. But I love that you thought that up. We'll talk about that later. Sydney?
Why is it 0.02?
So when you do 0.1 times 0.2, you get 0.02. So when you multiply them, I mean, you can put in your calculator, but when you multiply it out, 0.1 times 0.2, 1 times 2 is 2, and then we've got 2 decimal places, so I can move it 1, 2. Okay. Yep. Okay, now my last one, it says, if a candy is chosen from each bag, what's the probability that neither will be red? So what's the probability you don't get a red from Maggie? 0.8, very good. What about we don't get a red from Elizabeth? 0.7, good. Am I gonna multiply or add those two together? Multiply. I want that to happen. I want neither of them to be red. I want both of them to not be red. So I'm gonna multiply, and that's 0.56 or 56%. All right, you guys are doing awesome. That's the first of 2 skills I'm gonna do today. The next skill is a bunch of more problems. So like the 2 on this page and then the rest of the next side are all the same type of problem. But they'll start rolling pretty quickly once we get the hang of it, okay? Anybody have questions on the diagrams? Yeah. Okay, let's move on to this next one. This says, consider being dealt a 5-card hand from a standard deck of cards. All of these problems are using that scenario. So we're playing a card game of some sort and we're getting dealt 5 cards from a normal deck. Okay, that being said, there are some things about cards that we need to know that I think some of them you already know, but I'm just gonna make a list off to the side. Every year I have someone who's like, well, I don't know how many playing cards there are. And I'm like, oh, I thought we all did. So let's just go over it right now so we all figure it out. Okay, so how many cards are in a deck of cards? 52. 52.
That's good.
What you be doing? What you be doing? You be playing a lot of cards?
Yeah, I think some people play one card. Okay, how many colors are there?
This.
2.
Black and red.
That one.
Black and red, I know that. Ain't it, well, there's jokers?
We're not even gonna worry about jokers. Jokers don't matter to me. How many red cards are there? How many black cards are there?
2.
26 of each.
Close. Oh, I thought.
That's right, it's all right. There are 2 colors, and so that means of each color, there are 26 total cards. So if I say, how many red cards are there? There's 26 red cards. How many black cards are there? There's 26 black cards. Okay. The next category we could have is suits. How many suits do we have? 4, good. Do you guys remember what the suits are?
All I know how to play spades. What about aces?
Aces are a type of card. We'll do that in a second. Okay, so how many of each suit are there?
13.
13.
Okay, then.
All right, there's also, that means 13 different types of cards. So when I say type of card, I mean twos, threes, fours, jacks, queens, aces. So there are 13 different types, and there are 4 of each type. So there's 4 jacks, there's 4 aces, 4 twos. The last thing I want to differentiate between is face cards and non-face cards. So how many face cards are there? And to me, a face card means there's an actual face on the card.
King, queen.
King, queen, and jacks. So there are 3 types and there are 4 of each. So that's 12 total face cards. I don't count aces. I know aces are powerful in certain games, but they don't have any faces on them. So I don't count aces as a face card. What about non-face cards? If there are 12 face cards, how many non-face cards are there?
48.
I think just
40.
40.
Oh,
So I did 52 minus 12. So 52 minus 12 is 40. So that's where I'm getting that from. Now we'll have to do some other work in here, but I think this is like the most common numbers that I wanted to just kind of write down and we'll reference back to later if we need to, okay? So if I'm asking you like the probability of getting like all reds or all aces or all spades, like we had these kind of numbers to go back to and you don't have to calculate it every time. Okay? Everybody good so far? Okay. All right, so let's continue. The next one says, how many 5-card hands are possible? So I'm dealing the cards. Everyone gets 5. How many total cards are there and how many are you gonna get? How many total cards are there in the whole deck? 52. And how many can you get in your hand? 5. Okay, are we gonna do 52P5 or 52C5? Why is it C?
Because like, it doesn't matter the order you pick it.
It doesn't matter. If I get dealt an ace first, that's no different than getting dealt an ace last. Because most of the time when we play cards, you pick them up in your hands and you reorder them anyway, right? I always put like my colors together or my numbers together. Like I put them in a certain order for whatever the game I'm playing is. So the amount of 5-card hands possible is 52C5. And we're gonna put that in the calculator now. I'm not really gonna put in the calculator for the rest of class, but we'll put this first one in the calculator just so you can kind of see how we do it. So do you guys remember where NCR is and NPR? Math. Then now what? Probability. And then we just see it, right? So we want C because the order does not matter in which I get those 5 cards. I just need them all in my hand. So 52C5, which, whew, that's a big number. It's at 2,598,960 different ways that you could be dealt 5 cards. Now, that one just said how many 5-card hands are possible. If you notice, every other problem says, what's the probability? Letter B says, what's the probability? On the next page, what's the probability? What's the probability? What's the probability? What's the probability? Remember earlier, we said probability was what over what? Success over total. So I'm gonna have a specific situation where I say, I want these in my hand. So we're gonna do that, we're gonna do that like, option on top, and then the bottom is always gonna be the total amount, and we just found that total amount. So every single time I'm gonna put everything over 52, choose 5, 52C5. Okay, so all of these next ones, if it says what's the probability, you need a fraction. Okay. So what's the probability of being dealt a hand with all diamonds? Okay, how many diamonds are there? And how many do I want? 5. I want 5 in my hand. So I have 13C5. That's my number of successes. And then my number of total is that 52C5. And I'm not going to put in the calculator any more than this one, but let's put in the calculator to see what that is. It should give us a percentage or it should give us a decimal. So I'm going to do math, NCR 13C5. And I think I can just, as long as I make sure my division sign is big, I think I can just then divide 52C5. 1, 2. So was that 0.04? Is that different than what you got? Okay. I don't know what that E.
Or maybe I just.
Oh, you did get the E. I just have more zeros than you do. Let me make sure, let me throw some parentheses on that just to make sure. I'm very untrusting of the calculator. Let me put.
It's not.
It is brunch.
That is hilarious. Oh, thank you.
Okay, yeah, it's the same thing with or without parentheses. So do you see what a tiny decimal that is? We are not gonna get the decimal because it's gonna get really, really small, so I'm good with just this answer. I just want this. This is also easier for me to grade this way, okay? So I'm gonna put my calculator away, we're gonna do the next page. All right, the next one, it says, what's the probability of being dealt a hand with all face cards? Okay, how many face cards?
Oh, 12.
12, and how many do I want? 5, good, so I'm gonna say 12C5, and it's probability, so what's the total? 52C5. Everybody's with me, because we're about to get moving.
So when we do probability, doing C's.
When we're doing cards, playing cards, we're doing Cs. What's the probability of being dealt an all red hand? How many red cards are there? 26, and how many do I want? 5. 26C5 over 52C5. Very good. Ooh, the next one gets a little funny. It says, what's the probability of being dealt a hand with 3 jacks and 2 kings? Okay, let's take this one at a time. How many jacks are there? 4, and I want how many of them? 3, so I want 4C3. And also at the same time, I want 2 kings. How many kings are there?
So 5,
4, and how many do I want? 2. So I've got 4C3, 4C2. I want both of those things to happen at the same time, so am I gonna add or multiply in here? Multiply, good. You can do a little dot, you can do a little X, whatever makes you happy, I don't really care, as long as you know it's not a variable, but I need both of those things to happen. And then what goes on the bottom? 52C5, very good. Okay, what's the probability of being dealt a hand with no face cards? How many non-face cards are there? 40. How many do I want? 5. I want the non-face cards. So we counted how many non-face cards there are. We want all 5 of our cards to be those over
52.
Good. Okay. What's the probability of being a Delta 5 card hand and having all of the aces? How many aces are there? How many do I want? I want 4.
Wait. Oh, cause it's 4 and it's all.
I want all 4 of them. No, you may be really tempted to say, okay, I have 4 and I want 5. I can want 5 all day. Am I ever gonna get 5? There's no chance. Okay, that being said, the dealer's dealing, I get all my aces. Are they done? Do I just have my 4 aces and I'm done? No, I need another card, right?
52.
Well, not 52, because I already have 4 of them. 48. So and I don't care if it's a face card, I don't care if it's a 2, I don't care if it's red, I don't care if it's black, I just need another card. So I have my 4 aces, I've got another card that I need, it's all over 52C5. One thing I want to remind you is whatever you have when you're on top multiplying, these numbers should add to 5. That's already 5, 3 plus 2 adds to 5. You can't only get 4 cards in your hand. I can't be like, oh, I got all my aces, I'm done. You gotta get another card. We gotta have 5 total cards in our hand. Okay, what's the probability of being dealt a 5 card hand and having 2 10s, 2 jacks, and 1 queen? How many tens are there?
Oh.
And how many do I want?
Two.
Good. 4C2. How many jacks are there? How many do I want? 4C2 again. I want 2. How many queens are there? How many do I want? 1. 4C1. All over 52C5. Very good. Alright. What's the probability of being dealt a 5-card hand with no aces, no queens, no 5s? So that's how many cards that I don't want. I don't want 12 of them, right? So how many are left if there are 12 that I do not want? 40. So 12 that I'm not okay with, there are 40 that I'm okay with. I'm okay with the other 40, I just don't want these 12. So there are a total of 40. How many of those do I want? 5, good. You guys are doing so good. Okay, the last few are pretty similar. What's the probability of being dealt exactly 4 spades? How many spades do I want? Or how many spades are there? 13, and I want 4 of them. Sorry, I changed my question. There are 13, I want 4 of them. I got my 4 spades, now what? I need another card. How many cards are left that I'm okay with? 30.
39.
Yeah, but you had the right idea. We did 52 minus 13, and that says that there are 39 hearts and clubs and diamonds that I'm okay with. 39 C5. Oh, no, C1. That was a silly mistake. You guys were catching me. Over 52 C5. Okay. Now, look at the language in K and L. It says, what's the probability of being dealt at least 4 spades? And what's the probability of being dealt at most 4 red cards? Okay, let's think about what are situations we're okay with, what are we not okay with? If I want at least 4 spades, how many spades am I okay with? 4 and 5. And those are the only situations I care about because more than 5 I won't get. I'm only getting 5 cards. I am not okay with 0, 1, 2, 3 spades. Okay. This is like when we did our picking our candy from our bag and we had to deal with one situation and then we added that to another situation. We're going to do that here. We're going to figure out what is the probability that we get 4 spades and then we're going to add that to getting 5 spades. Now, the reason I listed no is whichever one of those lists is shorter, that's the one we're gonna do. So this one's shorter, so we're gonna do that one, okay? So what's the probability that we're gonna get 4 spades? Have we done that yet? Good, 13C4. And then do I need another card?
Yeah.
How many cards are left that I'm okay with? Good, good, this is exactly what we just did a second ago, right? However, now we're not done with that. We have to be okay with another situation. We're gonna add, what happens if I get, what's the probability of getting 5 spades? 13C5, very good. All of that together is gonna be over my total. Good. I'm okay with 4 spades. I'm okay with 5 spades. So I have both of those situations right here. I'm gonna add those probabilities together, divide. Great question. There are 13 spades and we got 4 of them. Now we have to get another card because the cards are still being dealt around, like we're gonna get another card. There are 39 other cards that we're okay with, and that's when I do the total amount of cards minus all the spades.
Why did we do that there?
We did it on letter J. I just don't think it came up yet. Like, I don't think that there was a time, like the one where we needed another card up here on letter G. It said we want all the aces and then we want a non-ace, so we did 52 minus 4 to get a non-ace, so that's how we got 48 on letter G. Other than that, I don't think it had come up yet. Okay. Let's do, what's the probability of being dealt at most 4 red cards? Okay, what are we okay with? And what are we not okay with? I think we're also okay with 0 red cards, right? But what are we not okay with? 5, okay. Now, we could do the okays. I could find out what's the probability we get 0 red cards, plus the probability we get 1 red card, plus the probability of getting 2 red cards. You're already sick of listening to me talk, right? We would have to do that so many times. 1, 2, 3, 4, 5, because there's 5 scenarios we're okay with. What we could also do though, is find out what's the probability of what we don't want, and we can minus it from 1. Why am I gonna minus it from 1?
Because only one of us.
Because it's what? It's 100%. So these are all fractions, and so the total of all these fractions working is 100%. And so if we do 100% minus what we do not want to happen, we're gonna get all the situations we're okay with. We could have done it with the one above it, but to do the no's, we would have had to do 4 situations versus just 2. So if you remember with the one above it, I said, we're gonna do the list that is the smallest. So in this case, the smallest is the no, so we have to do 1 minus it. If the smallest was the yes, we just add the yeses together. And you could still do it here. It wouldn't be that hard. It would be what, like 26 choose 0 times 26 choose 5, and then 26 choose 1 times 26 choose 4. Like I could make it happen, but it's a lot easier to just do the no. So if we don't want 5 red cards, what's the probability we would get 5 red cards? How many red cards are there? 26. And we want 5 because we want to subtract that off the total. So we want all 5 of them. So we're going to do 26C5 over 52C5. Okay, I think class is about to be over. We should have had time for M, but we ran a little long and that's totally okay. We can hit letter M tomorrow. I still want you to attend all of your homework. We're gonna go over it, but I want you to try it. There's gonna be a couple that are maybe a little bit different, but I still want you to give it your best shot. Let's talk more tomorrow. We'll go over homework, we'll quiz, we'll learn more of 9.3.